And we're off. Okay, so it's Wednesday the 9th. We're doing some more volumes of Revolution, more disc questions. Take a look at 83 AB4, which says, let's see, load up, stupid smart board, smart notebook. Come on, load up. Okay, go away. Go away. Go away. Go away. Okay. So, 83 AB4 says, consider the curve rad x plus rad y equals 2. Remember, that's the astrid that has a y-intercept of 0, 4 and an x-intercept of 4, 0. All right, the figure above shows the graph of that equation. Let R be the shaded region between the graph, the x-axis, and x equals 1, x equals 0, right? Okay, so let's just take a look at that graph, play around with it. And let's see what we're doing. So here's the x-axis, here's the y-axis, here's the origin, here's the y-intercept at 4, here's the x-intercept at 4. It looks something like this. But they only want you to deal with the area between x equals 0, the y-axis, and x equals 1. So this is x equals 1. Okay? And we already figured out this area. Whoops. Previously, right? We found this area. But that's not the question today. Part A is find the area. Part B says, set up but do not integrate an integral expression in terms of a single variable for the volume of the solid formed by revolving the region R about the x-axis. Hey. So we're going to take this weird shape. It's almost a trapezoid, sort of, right? If this was straight. It's almost a trapezoid. We're going to revolve it around the x-axis. So what do you want to do today? Horizontal or vertical strip? Vertical would be easy here. Why? Because, well, look what you get when you draw a vertical strip. You have a Riemann rectangle which touches the axis of rotation and is perpendicular to it. And we know how to set up volume problems like that. That's a disk. If you take this strip, this vertical Riemann rectangle, and revolve it, just it, around the x-axis, you sweep out a disk, right? A very thin cylinder. All right, so can we set up that volume? How would you get the volume of revolution about the x-axis? You have a circular face, and you have a thickness. What's the thickness of this thing? dx, right? Okay, now how do you get the area of a circle, the circular face? Pi r squared times the thickness would be the volume of that one slice, right? How do we add up all the slices? This is called a Riemann statement. I could call this dV, the volume of just this very thin sliver. But then if you integrate, you add up all the disks, right? This is just one disk, right? All right, so if you integrate, you're going to get all the disks. Okay. That's called a Riemann argument. So what does it go to? From what to what? 0 to 1. And what is the radius? What is this? This is the radius of rotation if you're going around the x-axis, right? Well, how long is that? It's the y value there, right? Okay, so how do you get y alone? Subtract the rad x. Okay, so rad y is 2 minus rad x. I want to get y, so y is 2 minus rad x squared. Now that's the radius. But what are you going to do to the radius? You're squaring that, right? So square that twice, it's really to the 4th. Okay, so we'll fix that. And you're done. That's part B, because read what it says. Set up but do not integrate. Why not? Yeah, it's a mess, but you could do it. It's not that you can't do it. It's not a U-sub, but it's a messy foil. You have to foil like 4 times or 3 times, whatever it is. It's not really foil. Foil is a binomial times a binomial. If you multiply 2 minus rad x times itself, you get a trinomial. You multiply that by 2 minus rad x again, you get a quadrinomial. Multiply that again by 2 minus rad x, you get a quintinomial. Then you got to integrate all that mess. All right, well, under time constraints, they figured, that's enough time spent on this question. Just set it up. But let's cut to the chase. Can't we ask Hal to do it? Sure we can. All right, whoops. Hal, wake up. Okay, so let's just get an idea of what the answer is from Hal. All right, so what is it? It's going to be pi. There's pi. And the integral second 7 of the quantity 2 minus rad. There's your rad. X. Close the rad, close the quantity. We're taking to the 4th, right? comma x. Now, if I just do this, what do I get? The antiderivative. So that presupposes you FOILed 4 times, and you integrated, and you get this humongous mess, and of course Hal has to write it in factored form, but it's humongous. Look at this. It's ridiculous. Okay. All right, we're not doing that. So let's just get the answer. Comma, 0, comma, 1. Let's get the area, the numerical integral. Apparently is 19 pi over 5, and if I wanted a decimal equivalent, it would be 11.938 something. Okay, so if I wanted an exact answer, I could write it. Was it 19 pi over 5? Okay. So equals 19 pi over 5, or is approximately equal to, what was it now? 11.938? Okay, 11.938. Okay, that's it. If you were in the non-calculator active section, they would expect you to do this. Either they would say set up and don't integrate, or they'd tell you, go ahead, FOIL it out and finish it, and you get this. If you were in the calculator section, you would be asked to set it up and give me an estimate. That's it, done. Write that and write that, you're done. By the way, on the calculator section, do not write your work down like, oh yeah, I hit second 7, and don't write stuff like that. Just write the setup, write the answer you get from the calculator, boom, done. Okay? Well, because there's no need to do that. So you're not going to get points for that, you're just going to waste your time on the test. You got the limited amount of time, right?
Well, why did teachers say you have to write like, oh, I did this?
Well, if you're showing the work here involved would be foiling, doing algebra, then doing the power rule of anti-differentiating. If you were showing the work, yeah, show everything. But no, really, they do that? They ask you to write down the keystrokes? That's silly. That's just silly. Well, I didn't say nothing. All right, well, how much time are we at?
We're at
Almost 9?
9 minutes.
Almost 9. All right, let's leave that for our YouTube. It's 7 something? That's good enough for today, for the YouTube. All right, so I'm going to